Hi, everybody. My name is Shedrack Akintayo. So my talk today is a very personal one, yeah? It's titled From Frontend Engineering to Cloud Native, Lessons Learned from a Beginner, right? I'm a beginner, cloud native newbie here. So yeah, what do? I am a community manager for eBPF and Cilium and at Isovalent, who I'm pretty sure you guys have heard about Cilium and eBPF. If you have, let me see your hand up. Let's represent, please. Nice. Okay, so let's embark on a cloud native journey, right? So we're just going to go through a couple of topics. So I'm going to take you through my transitioning from front-end to cloud native, then maybe a bit of an anecdote on cloud native, then technologies powering cloud native, valuable insights from my journey, like my advice, and then, conclusion and resources. So my story, right? So before all of this, before cloud native, I used to work as a front-end engineer for startups, right? I worked in the e-commerce industry, I worked in health tech, I also work in the SaaS industry. The irony about all of this is I really dislike CSS. I am a front-end engineer, but I dislike CSS. So I use JavaScript and TypeScript mostly, and I decided to transition to cloud native because in every single job I've been at, there was one role that was always coming up in conversations: cloud and DevOps engineering. And that got me really, really interested. Like every single meeting I am in, I'm hearing DevOps, cloud, native, this and that. But I didn't really understand, what that really meant. So, one thing about curiosity is it drives you down a rabbit hole. So I'm basically going to just show you the rabbit hole that I've been through. So some of my skills that were transferable to cloud native, APIs, JavaScript. I mean, I can write some services with TypeScript and Node. Then that's about it, right? So I had to learn a whole new set of skills. So first things first, let's talk about cloud native, right? Anybody here that doesn't know cloud native like me? Okay, nice. Twins. Okay, so cloud native is basically, I like to think about it as a philosophy, right? An approach to building and running scalable applications to fully leverage cloud-based services and delivery models. So the key words here is cloud-based services and then the delivery model. That's basically the idea behind cloud native. Nothing too complex, nothing too funky, right? So it adapts to numerous possibilities and architectural constraints offered by cloud compared to, traditional on-premises infrastructure. If you've been a DevOps engineer or a sysadmin at some point, you know that managing on-prem infrastructure can be quite a pain, right? So the cloud native model or the cloud native approach makes things a bit easier, right? Not a bit, way easier. So the benefits include increased efficiency. You get the chance to basically automate everything. I mean, CI/CD basically, DevOps basically makes the whole process of automation easier. Then you have cost reduction, which means $0 spent on managing on-prem servers. This is what upper management loves. Zero money being spent on infrastructure, right? Managing on-prem servers, rather. So reliability, I mean, for every single software application, your software is as good as how reliable it is, right? It's resilient, it provides resiliency, and it's provides really highly available applications. So let's talk about cloud and cloud native. These are two very confusing concepts, right? Cloud native. So first things first, cloud is not equal to cloud native, right? Any disagreements here? Okay, good. So cloud usually refers to cloud computing. It involves on-demand availability of computing resources. So too long, don't read. You do not need on-prem resources, right? Everything is on demand. What you need memory, you need RAM, anything, it's basically on demand as you request it, right? And cloud native, like I mentioned earlier, is a method or approach through which applications are built and delivered rather than resources they use, right? Instead of worrying about, the resources applications use, in cloud native, you are much more concerned on the method in which applications are built and delivered. Right, so these are the differences between cloud native and cloud, right? So it's good we don't make that, that mistake again. Okay, so let's talk about the principles of cloud native. the principles are quite very popular. I mean, at some point in your cloud native journey, you would hear about microservices, containers, like containers orchestration, service mesh, and immutable infrastructure. So microservices basically involves breaking down your application into very, very small and in a very composable manner, which means you have lighter weight services, like your applications are like broken down into smaller parts, and then you can down connect every single thing via APIs, right? Then container orchestration, which is like and containers, which is like the heart of cloud native. I might be wrong or not. Containers help package your application code and its dependencies into an image that can then be run on any machine. So if you've been in the JavaScript ecosystem, package management can really, really be a pain. I'm actually, yeah, it can really, really be a pain because in JavaScript ecosystem, there's a package for everything. Even if you want to find if two numbers are even, there is a package called isEven, and it has almost 2 million views, 2 million downloads every single week. So that's how package management is really, really serious in the JavaScript ecosystem. So bringing it here, containers basically do the same, right, on the cloud native space. And orchestration itself involves helping, managing containers so they can run smoothly as an application. A very popular container orchestration tool is Kubernetes, which is literally the order of the day, right? Service mesh, which is a very, very tricky and complex topic, is a software layer in the cloud infrastructure that manages communication between the multiple microservices, right? It stands as a mediator between the services in a microservice, right? It stands in between there. It stands as like a communication tool. Then lastly, another like really, really important concept or principle of cloud native is immutable infrastructure. It means this is basically the best selling point. If I am making a deployment, right, my application should remain unchanged, right? There shouldn't be zero downtime, right? Every single part of the application should still remain the same, even after deployment, which is one of like the mind-blowing, concepts of cloud native. So moving on, let's talk about containers a bit, right? So like I mentioned earlier, containers are a very lightweight. Lightweight is actually the very key word here and selling points for containers. Standalone executable packages that include everything needed to run a piece of software, including the code, runtime, system tools, basically everything. It makes building applications in any type of environment easier if you just package it in a container, right? It makes every single thing easier. Making reference back to my JavaScript experience, right? If an application, the way an application runs in a browser is going to be quite different from how it runs on Node. There's some APIs of JavaScript that doesn't work in Node that actually works on the browser. For example, fetch, right? So containers, like in the same context, right? Containers make this thing easier because right now you can package every aspect of your application, every code, runtime, system, package anything you need, and then put it in a particular image. Right, that's what containers. Then you can now run it on any platform you probably want to run your application on. Then the benefits of containers include isolation, and then of course it aids microservices. Then portability. Containers can basically isolate software from a particular environment to ensure that it works correctly, uniformly, despite the differences between development and staging, which is always like the normal development workflow. When you're building an application in a team, there's usually development, staging, there's also production, right? So container makes this whole process easier. Then portability, it ensures software runs consistently across various computing environments, which is like my favorite part. I do not have to worry about fetch not working on Node, but working on the browser. Very, very important keyword. So aside containers, let's talk a bit about other technologies that power cloud native. Okay, I'm still on time. So a container runtime Let's talk about container runtimes, right? Since we talked about containers. A container runtime is a software that executes containers pretty much easy, right? They are one of the fundamental components of any cloud-native environment that includes containers. Some examples is Docker engine. I'm pretty sure we know. Does anybody here know Docker? Okay, nice. When I said, does everybody here know Cilium? I didn't see this much hand. You should do better. Okay, so Docker engine is a platform or tool for building, distributing, and running Docker containers. It basically serves as the powerhouse for any single container that you run on Docker. Then Containerd, which is also an industry standard core container runtime, is available as a daemon for Linux and Windows and can manage the complete container lifecycle of its host system. Then LXC, which is not quite popular. It's not exactly really popular because people do not really have to worry about this for the most part. But LXC, also known as Linux Containers, is an open source container platform that provides a set of tools, templates, libraries, and language bindings. Then some other container runtimes include runc. It is managed by the Open Container Initiative, OCI, and it's basically a CLI tool for spawning and running containers on Linux according to the OCI specification, hence why it is managed by the OCI. So Creo is an implementation of the Kubernetes container runtime interface to enable using OCI compatible runtime. That's basically what Creo is. Then after this, we've talked about containers, we talked about container runtime. Let's chat a bit about Kubernetes. So I'm going to ask again, do we know what Kubernetes is? I want to see your hands up. If you know what Kubernetes is, let me see your hands up. Oh, nice. Not so much hands. Interesting. Okay, so let's talk a bit about Kubernetes. So Kubernetes is a prominent container orchestration platform, which it helps, create containers. It manages where containers run within a cluster of servers. Then it also moves containers between servers to keep load balanced. So there are 4 ways of using Kubernetes, however you choose, right? 4 ways. Vanilla Kubernetes, use Kubernetes as it is. Then manage Kubernetes via a cloud provider, Google Kubernetes Engine, AKS, EKS. Then you can decide to use a Kubernetes distro like Rancher or OpenShift. And there are even more lightweight distros for practicing Kubernetes or doing hobby projects and things. I do not advise anyone to use lightweight Kubernetes distro in production. Minikube and Kind. These are in every single demo you probably see for anything related to Kubernetes, they most likely are running Minikube or Kind for development purposes. Then let's talk a bit about the basic components of Kubernetes. So there are 3 important things in Kubernetes, right? There are pods, there are nodes, and there's the control plane. These are the 3 most important aspects of Kubernetes. So the pod is like a cell, right, in the human body, which is the most basic form of every single human being is a cell. So the pod is the smallest deployable unit in Kubernetes that can hold a single container or multiple small, tightly coupled containers, right? So it's the most basic, the most basic units, small deployable units of Kubernetes. Then nodes, just the bees, right? They are worker machines that help run containers. Then the control plane, it's basically I like to call it the central processing unit, right? It coordinates all the activities in your clusters, then such as scheduling applications, maintaining applications, desired states, scaling applications, and rolling out new updates. The control plane basically serves as the CPU for everything that happens in a Kubernetes cluster. So this is a diagram that basically represents how a Kubernetes cluster looks like. We have the nodes with kubelets in them. Then we have the Cloud Provider API if you want to use it with as a managed Kubernetes. Then we have the control plane, which basically serves as the control unit, and every single part of the cluster is connected to the control plane. So what's the importance of Kubernetes to cloud native, right? Everybody's talking about Kubernetes. Kubernetes. I hear Kubernetes at least 100 times a day. Why is this particular two really, really important to cloud native. The first part is scaling, right? It manages the scaling of applications as per the demand. The good thing about Kubernetes is how it helps, restart containers that fail. I really like that particular aspect of Kubernetes because it ensures that your applications are constantly reliable. Then load balancing. It distributes network or application traffic across many servers, right? In a situation where everybody wants to watch the World Cup, or everybody wants to watch a particular YouTube live stream or something, traffic increases, right? And if it's just a single server, if it's too much, it can actually crash, right? That way, nobody watches the World Cup. But with Kubernetes in place, it can handle, load balancing across several servers that have been provisioned for that particular viewing event. So if one server doesn't work correctly, the other servers automatically take their place and keep the whole match viewing going. Then healing. Earlier, like I said, it replaces and reschedules containers when they fail. This is like my favorite aspect of Kubernetes. Because every time I'm sure that, something always would help me figure out places where I've made mistakes. Then rollouts and rollbacks, it manages the updating of applications without downtime and rolls back to previous version if issues arise. Brilliant stuff. So let's talk a bit about serverless, right? Like the name implies, serverless. Do we have any experience with serverless? Anybody here has heard about serverless? Okay. There's like a bit of, I would say, conversations in the ecosystem about serverless. So let's have that conversation. So technically, serverless, despite it being serverless in quotes, what the idea is, you do not have to worry about managing a server, right? But don't get it wrong. There's actually a server. That's the most interesting part. But the entire selling point is that you do not need to worry about managing that server. It lets you, the entire concept basically lets you execute applications on demand without having to install them on a server, right? You don't have to worry about managing a server. So you only pay for what you use basically, right, on demand. And it can be set up as managed in a public cloud, AWS Lambda, on-prem, or self-managed with OpenFaaS or OpenWhisk. Then let's move on to load balancers. I'm still on time. Okay. So, like I was using the whole traffic. When you're trying to watch a particular viewing and you have to split, the traffic across different other servers. That particular tool responsible for doing that is actually a load balancer. So, because most cloud-native environments include like multiple servers with various workload, load balancers help distribute the traffic or request across a cluster of servers, ensuring there is high reliability and availability. Now everybody can watch what we want to watch on easily without having to worry about, we are too much watching it. So some very popular examples include Nginx and Cilium. So Cilium has a layer 4 XDP load balancer, which is based on eBPF, which is why I asked, do we know eBPF? And I saw some really good reception. So by the next time I'm coming back for KCD UK, I will see ask this question and hope there's so much more people raising up their hands. So Cilium provides full IPv4 and IPv6 dual stack support that can be deployed and programmed independently of Kubernetes, right? Aside Cilium is also a CNI for the most part, but it also has an arm called, that handles, load balancing, and it provides, full support for both IPv4 and IPv6, and it can be programmed independently of Kubernetes. Moving on, let's talk about CNIs. Right? We've talked about container runtime, we've talked about containers, but we've not really spoken about, the networking of containers, right? What helps, container networking. So a CNI, also known as a container network interface, is an initiative of the Cloud Native Computing Foundation, the CNCF. Do we all know the CNCF? Okay. Okay, we're going to talk about the CNCF a bit more later. So it basically specifies the configuration of Linux container network interfaces. And Kubernetes itself has a built-in CNI called the Kubernetes CNI, right? It handles most of the networking in Kubernetes. But in situations where this particular inbuilt CNI in Kubernetes is not enough, right? There's different other specifications of CNI that you can also bring your own CNI to Kubernetes. Some very popular examples include Cilium, Calico, Flannel. Cilium is an open source cloud native solution for providing, securing, and observing network connectivity between workloads fueled by eBPF. Once again, eBPF comes into the conversation. So yeah, so Cilium is basically responsible for handling everything related to providing security, observing network connectivity between workloads, and the most interesting part is the in-depth visibility that eBPF gives Cilium. Okay, so let's talk about eBPF. So eBPF is basically a technology used to extend the capabilities of the kernel without requiring to change the kernel source code or load the kernel model. So basically, you can extend, with eBPF, you can extend the capabilities of the kernel safely without worrying about anything like changing the kernel source code or loading kernel models. It's also, the reason why I'm talking about eBPF is because it has enabled the development of new powerful tools for the cloud native ecosystem that offers like enhanced observability, efficient networking, performance, and it's basically revolutionizing the way tools are being built in the cloud-native ecosystem. Some very popular eBPF-based cloud-native tools is Parker, which is a continuous profiling tool built that leverages eBPF. Pixie is also an observability tool that leverages eBPF. Cilium, like I spoke about earlier, does like container networking and Kubernetes networking. And then Tetragon, which is also part of the Cilium project, handles security with eBPF. Now, I have basically given the theories, right? Like, yeah, this is all I know. This is the rabbit hole I went down. But if someone from someone trying to transition into the cloud native ecosystem asks me for advice, right? The first thing I will start with is Kubernetes is hard. It's really, 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 really hard, right? And it's okay if you don't get it immediately. It's really, really okay. It's all about like iterating, trying out new ways to learn, and eventually it comes around. Also, do not rush your learning. Understand the basics, really, really important, which is one of the reasons why I touched on the cloud native model and I went through the whole why cloud native exists. Then, create a study plan. There are like different cloud native study plans, like, 90 days of DevOps. Then also the CNCF has this really nice website called the Cloud Native Glossary that answers, that talks about a bunch of the concepts in cloud native. Then, find out the type of learning that works for you. Is it video content? Is it written content? Is it project-based? It's really, really important to find a common ground between yourself and what you're trying to learn. Then, the cloud native world is ever changing. There are always new things coming up, right? There's always new ideas coming up, right? So it's important to cultivate the habit of reading content from platforms like this is not an exhaustive list. It's just specific because I read them. The new stack, Cloud Native Now, DevOps.com, DevOps content on, or Cloud Native content on Hackanoon. Really, really, really insightful articles are on all of these platforms that can help you grow as and also level up your cloud native experience. Then find a cloud native community. KCD UK, for example. I mean, you're hearing this talk at KCD UK. Please let's put our hands together for the team that organizes KCD UK. Please let's put our hands together. So yeah, KCD UK, you get to hear talks like this, get to hear talks from much more experienced people than I am. And yeah, it definitely help, your cloud native journey. Then there are what they call cloud native community groups, which is organized by the CNCF, like different groups you can probably find them in your region that have a common goal. It's come together to talk about cloud native, right? Cloud native tools, technologies, and concepts. Then with the most important advice of them all is practicing, right? Practice, practice, practice. Very, very important. And lastly, take some certification exams to showcase your skills. There's the KCNE, which is the Kubernetes and Cloud Native Associate exams. There's the CKAD, which is the Certified Kubernetes Application Developer, and the CKA, Certified Kubernetes Administrator. Before we go, lastly, let's talk about the CNCF, right? The CNCF is a Linux Foundation project founded in 2015. So they basically help drive the adoption of the cloud-native principles and models by fostering and sustaining an ecosystem of open source, right? They also help make sure that there are vendor-neutral projects in the CNCF. And yeah, this is why we love the CNCF. So this diagram shows the landscape of the CNCF, all the tools for its various categories under the Cloud Native Computing Foundation, either being incubated or graduated. And yeah, that's the end of my talk. Thank you so much for coming. Any questions? There's time for questions.
Yeah.